Hello and good morning, good evening, everyone, depending on where you are in the world joining us today. Welcome to a global webinar series brought to you by Rockflow Dynamics. My name is Jessica Kalin from the RFD Calgary office, and today with me is Senior Reservoir Engineer Horatio Del Campigio. We would like to thank everyone for joining us today. We've been overwhelmed with the response from these sessions and hope that you enjoy them as much as we do. During today's webinar, all of the attendees' microphones have been automatically muted. However, we still encourage questions. Throughout this presentation, if you think of any question at all for our presenter, please feel free to navigate to GoToWebinar control panel on the right-hand side of your screen, where you'll find the questions pane. There, you're welcome to submit any question that you have, and at the end of the session, we're going to answer as many as we can. If we don't get to all the questions, time depending, then we'll respond to you individually via email with the answers to those questions for you. One last note is that this webinar is being recorded. So if you would like to view or share with your colleagues in the upcoming days, you can find it on our YouTube channel if you search Rockflow Dynamics Europe. Each webinar in our series has covered a breadth of topics. The ones that are coming up next week that we're excited for are on the bottom of this screen under week 3. So next week we have understanding the effect of 3D grid layering on your production profiles, as well as tNavigator, the future of reservoir modeling. Each of our webinars touch upon a different aspect of tNavigator's integrated reservoir modeling process. We have a single platform that allows you to build your static model and take it all the way to running simulations, both from surface as well as reservoir. Now for today, we're live from Buenos Aires, and I would like to introduce you to Horatio Del Campigio, who will talk to you about history matching your model using repeat formation test data. Horatio, over to you.
Okay, thank you, Jessica. Can you see my screen? Yeah. Well, okay, thanks. Okay, well, I'm going to talk about this history matcher model using repeat formation testing. My name is Horacio Del Campillo, and what we are going to discuss here is, well, we have an agenda that we are going to first open a model, run the model, then we are going to compare the RFT data results versus the data that we upload in the model, and compare and do an analysis of the mismatch. Do the automatic history matching, compare the results from these best models that match the observed data, and questions and answers. For this, we are going to work with a simulation that is a post-processor for analyzing the results, and where you can do also some minor modifications to the models. And also we are going to work with the module assisted history matching and uncertainty. So moving forward, the most common problems we can face when doing an assisted history matching is working with RFT data. Many times we face problems like having a few data of RFT, so like a sporadic data. So we want to use this data also for matching our models. Other things is like complexity to combine different objective functions, or lots of data editing before doing the assisted history matching processes. And of course, one of the main problems that we have to face is running lots of simulation cases in order to get a proper match. So for this, you can use tNavigator in order to help yourself to match your model, not only rates, but also the RFT data. So for this, tNav is simple and fast to make this workflow. It's flexible in order to combine different kind of objective functions, and the setup, you will see it's pretty simple. So in order to work with these workflows, one of the things we need to take into account is the trajectory of the wells. For example, here we have X, Y, Z, and MD data, and we need to have this in order to then be able to import the RFT log in order to combine the measure depth of the RFT with the real trajectory of the well. The calculation of the RFT pressure is calculated in each grid block where well trajectories intersects the mesh. It is calculated as a linear function, basically interpolation of the pressure in the date of the measurement. As you can see here in the formula, P1 and P2 pressures are reporting in every single time steps, and between these pressures is the RFT measurement data. We can also add, for example, different zones in order to do a better quality of the mismatch. In this case, in the table that you have in the left, you have different zones for different layers and different reservoirs. And in the right side, you have the difference between the measured data versus the calculated data. And then you can compare the relationships between wells and as a whole for the zones and reservoirs. The mismatch for the wells in these zones is an arithmetic mean of all mismatches. And it uses the same method for all the different zones and wells. So related to the demo, what we are going to do here, it's a short video where you will see how I upload the RFT data, run the model and compare the mismatch, and then use the process of assisted history matching for the model. So we are going to use simulation and assisted history matching. First, we need to open the base case. It's a .data file where we have all the grids, the skull, PVT, wells, everything. In this model, we have 5 models. 4 are producers and 1 injectors. As you can see here, well 2 is the injector, well 6 and 10 are the producers. And those wells we are going to focus on. So first, we need to bring the trajectory, as I said before. The trajectory has it can be imported in different formats. We are going to use a trajectory format. It's the one I showed you a couple seconds before. And now you see that we have the trajectory of the wells. With the trajectory uploaded, we can bring the RFT log data. As you see here, you have the well name in the first track, then we have measure depth, the pressure data, and the dates. So after we import this log data, we can visualize the log data, but we need to tell the simulator that this log is related to RFT. Also, you can relate these logs to PLT if you have PLT data. Now we can start the simulation, and automatically we'll start calculating the RFT for the simulation. We can plot the 2 logs together. I'm going to change the color here in order to have a better visualization of the 2 logs. And we see from log 10, from well 10 and well 6, the differences between the calculated and the log data. Also, a couple of things that we can do while the simulation is running, visualize streamlines, see how the connectivity between this well 2 with the other wells how well is the performance and the connection between these wells. Of course, some transparency in order to visualize the results. And then other things that we can do is compare the zones error. Yeah. So as I was telling you before, these are the mismatch of the different zones, average mismatch from the reservoirs, etc. And also you can also see the well performance, water rate and oil rate, how far we are. So now let's move forward. Let's open the history matching project. We are going to use different variables, multiply of permeability for the different zones we have already set up. I'm going to call it RFT test webinar. Save. In these first windows, you can set up the amount of simulation cases you want to run at the same time. Also use GPU in order to accelerate the simulation. And here you can set up the different kind of algorithms and the objective functions. In this case, we have to create an objective function that I'm going to call it RFT. Set up the object that I'm going to match, RFT for well 6, well 10, and set up the parameter, Rft pressure, and then set up the different optimization I'm going to use. 100 cases is good enough for this example. Select the objective function, press OK. And now, if you go to Calculations tab, you will see that I have 3 cases running at the same time, and we will be able to start doing the comparison as soon as we finish some of these cases. While the simulation is running, I'm going to get the RFT mismatch in the table in order to see in values how good or bad is the mismatch. So my cases are running. I have to move forward with the video in order to get all the results. So the best case so far is case 19. I will stop the experiment. No need to have more cases running. With the case 19, I can open the model and compare the RFT observed data versus the calculated. So we go to well section, well logs, well 6 and well 10, put the two logs in the same windows, in the same track, and as you can see, the matching is pretty good. If we compare with the base case, I will open it again. Well section, well 10 and well 6, and well logs. The two logs are in the same windows. The difference is bigger. So we managed to get a proper match of the RFT. But now, what happened with the rates? If we plot, for example, well 6 for oil rates and oil rate history plus water rates, we see that the match, it wasn't that good. Okay, so we now can combine or create another experiment and take into account the RFT plus the different rates from the wells. So let's create another objective function. We will call it rates, and we are going to use the same wells, well 6 and 10, and the parameter will be oil rate, and the second term, it will be the same but with water rate. So let's create a new differential evolution case. I'm going to put global search, multiple objective function, and select RFT and rates. In this case, it will take into account both multi-objective, both objective functions in order to do the comparisons. So, well, this is okay. And the cases are now being, now they are running. So you can see experiment 2. And I'm going to bring again the mismatch rates in the table to see the values of mismatch and be able to compare with RFT mismatch. Now you see column of rates and column of RFT and the values of mismatch. In this case, the best match for rates is experiment 1, case 26. So if I move forward, now we have different experiments, and I have now experiment 2 version of 23 with the best case for rates. and 19 it was for RFT. So let's compare the simulation cases. Let's open case 23. So for case 23, as you can see, the RFT is better than the base case, but not as good as case 19. But if you compare now with rates, they are pretty close. So this is how you can work with different objective functions, start working to get a better match, not only for the RFT, but also for the simulation case. This is the base case. As you see, the differences are pretty big for rates and for RFT. So I would say like case 23 is the best match so far. The simulations are continue running in order to get a better match so far. This is the best RFT match, and you see the differences in the rates. Other things that you can do is plot everything inside the assisted history matching and uncertainty process. So you can select the cases you want to visualize here and compare the different cases, like for rates, for example, with the base case, the historical value, and plot in graphs. Let's go to well 6 and press historical values, and you see how good are some of these cases. Since the simulations are continue running, I get new feedback from the cases that are being run. So this is the demo. So as a summary, with this tNavigator, you can take advantages of the integration between building a model and running simulations, running sensitivities and optimizing your model to map the history of the field. tNavigator is fast simulator with high speed and allows you to run many more cases in less time to achieve your goals. And you can also take advantages of this simple step-by-step to help yourself to history match your model, not only with the typical approach, but also adding a RFT to the matching process.
Wonderful. Thank you very much, Horatio. That was a great presentation. So again, if you missed any part of the presentation, you want to go back to it, or you want to share Horatio's presentation today with a colleague, you're welcome to find it online on the YouTube channel under Rockflow Dynamics Europe, as well as on our LinkedIn page. The next session will be on Tuesday, July 7th at 800 hours UTC, and the topic will be on understanding the effect of 3D grid layering on your production profiles. This is just a quick demonstration of what that looks like in your time zone. So 800 hours UTC will be the middle of the night for Calgary and Houston. However, it will be central day for UK, Moscow, Abu Dhabi, Perth. So quickly take a look at this, see where these times meet your current time zone and which presentations you're able to attend. Now I'm going to hand it back to Horatio to go through a few of the questions that have come in from the audience. If you still haven't had a chance to get your question in, no worries. Please feel free to type it into that questions pane now. And we'll be sure, if we don't get to it today, we'll be sure to email you in the next couple of days with an answer to your question. So Horatio, I'm going to hand it back to you for some questions.
Okay, thanks, Jessica. Well, I see that there are a couple of questions coming. Some are really interested. For example, what other methods can be used for optimization? Well, there's plenty of methods. Can be ensemble, particle swarm optimization, response surface, simple methods. We use differential evolution for this demo, and also there's artificial intelligence. So you feel free to test any of these methods if you have the chance. Also, is it necessary to set up the zones? Well, it's not necessary, but it will give you some feedback how the performance or the matching is being done, and may help you to do the analysis how to match your RFT. Also, well, yes, can we use PLT for this? Yes, as long as you set up in the correct way, you can bring any log and tell if it is a RFT or if it is a PLT gas oil, and you set up that, and you can use also to create this objective function using this PLT. Okay, there are some other questions. Perhaps we can discuss this and lately, and send by email the answers, if it is that okay.
Wonderful, thanks, Horatio. And have a great day, everyone. If you have any questions at all, feel free to email us in the upcoming days at asktnav@rfdyn.com. And thank you very much, everyone. Stay safe.
Thank you.